The next topic is Hibernate Basics. So this is the presentation and the lab in which we are going to learn the concepts. In Hibernate step by step, the goal was to get you started. So we haven't really looked into the concept behind of the code and everything. So here we are going to look into those concepts in detail. So we have in fact bunch of topics that we need to cover. So first topic is ORM, object relational mapping. So this is basically why ORM is actually needed. And then we are going to talk about what is and why Hibernate. And then we are going to look into Hibernate architecture a little bit and the domain classes and instance state. And then persistence lifecycle operations such as a save, get, load, and things like that. And we are going to take a look at Hibernate framework classes such as the session factory and session and things like that. And we are going to look into Hibernate configuration and then object to table mapping, and the last topic is DAO pattern. So some of these things you have already got some exposure in step-by-step presentation. Here we're going to actually mostly focus on understanding the concepts. The topics that we are going to cover in other presentations, so the query API, such as the criteria API, HQL mapping, fetch mode, N+1 select problem, and caching and transaction locking. So these are the topics that we are going to cover in other presentations. So here, these topics are not going to be covered in this particular presentation. So these are the set of topics we are going to cover in this presentation. All right, so why use ORM, object relational mapping? So this is just a basic concept. Oops, sorry. Oh, looks like, okay, so this slide is actually located in the wrong place. I made some changes and I guess I placed in the wrong place. Okay, so why object and relational mapping? So ORM mapping handles object relational impedance mismatch. So this is the what we call impedance mismatch between object model and the relational model. Relational database is table driven with rows and columns, and it is designed for fast query operations based on this table driven data. However, Java code, we deal with Java code in terms of classes and object. There is intrinsic mismatch between these Java classes and object with these tables, which are basically rows and columns. So somebody has to match the object to the table and vice versa. Okay. So if you're not using ORM, you have to do this matching yourself. For example, if you're dealing with JDBC directly, then what you have to do is that whenever you perform JDBC SQL, you get the data, then you have to get the data, and then you have to set the values of your object yourself. Okay, that is a lot of choice, especially the object model is complicated. Okay, so ORM mapper is actually doing this mapping for you. So you as a developer focus on Java code, and whenever you persist the Java object into the table, the mapping will be automatically done by ORM mapper. Okay, and the ORM mapper has been around for a long time, so they are pretty mature and highly optimized. So there is really no reason for you not to use this ORM mapper technology such as Hibernate. So what is and why Hibernate? So Hibernate is one of the most popular this ORM mapper, so basically let you focus on Java code without being constrained by table-driven relational database model. Okay, so you don't have to work on low-level JDBC APIs anymore. Instead, you are working with the Java code. Okay. Enables transparent topology persistence. So basically, you are taking advantage of all the object programming models, such as inheritance and polymorphism, encapsulation, and all those things. And the mapping to the table will be done by, in this case, Hibernate. So Hibernate is, as I said, one of the most popular ORM mapper, and the reason is because it provides high performance. It supports like a caching, and you can configure the mapping in many different ways. And it does provide a pretty comprehensive set of query facilities, such as a query API and query by example and Hibernate query language and native SQL. And it's proven in the marketplace. Now, before I move on, we're going to actually learn JPA later on. So one of the questions you might in fact have is which one to use, Hibernate or JPA. The trend is definitely JPA, and in fact, the trend is using JPA as an API layer. So you write your code using JPA, which is a standard API in Java community, so that you have portability of your application. Now, JPA, as we are going to learn later on, provides what is called the pluggable persistent provider architecture, which means you can pick and choose a proven persistent provider. So you can actually use Hibernate engine as a persistent provider. So you take advantage of all the proven performance and scalability and all those things while maintaining your code in a portable fashion using JPA API. Okay, so that's typically the trend that is being recommended. So Hibernate architecture. So on the bottom, we have a database, and we have the mapping, XML mapping, or you can use annotation. And then you have Hibernate configuration files. And then we have Hibernate as a framework, as an OL mapper. And then you have a persistence object. So these are the Java objects that are maintained in a session or persistent context, and we're going to actually learn the concept of those session and the persistent context in detail later on in this presentation. Then you have an application on the top. Okay, so this is a bit more detailed. So you have a database, and you can have different layers, JDBC, JTA, and JNDI. And one of the advantages of Hibernate is that the Hibernate could actually kind of hide these low-level APIs. Okay, so Hibernate provides these high-level APIs such as a session factory, session, transaction, and on the session factory has a transaction factory and connection provider. Okay. And then application will work with the persistent objects. Those persistent objects are basically maintained within a session, and then there could be what is called the transient objects. And we're going to actually talk about the concept of transient object versus persistent object in detail in a few minutes. All right, so let's move on to domain classes. So domain classes are classes in your application that that implement the entities of the business domain. For example, customer, order, school, student, and things like that. Okay. These domain classes are POJO classes, plain old Java object class, with a little bit of rules. For example, as we are going to learn in a few minutes. It has to have no argument constructor and things like that. Okay, so the steps for writing this domain class is pretty simple. So step number one, you have to have no arg constructor. Okay, and you have to have identifier property. So you have to have a field. Typically, you're going to name it as an ID field, and that is designated as identifier property, and it actually maps the primary key column of your table. Okay, the property can be called anything, and its type can be any primitive type or wrapper type. So it could be string or it could be date, and composite key is also possible. And you also have to have a getter and setter methods for those fields. So these are the things that you have. These are the rules to follow for creating domain class. Okay, so basically domain class is a POJO class with these characteristics. Okay, so instance states of domain object. So instance state means an instance of a domain class. For example, if you have a person class and you create the person object, right? And that person object could be in one of the three different states. Okay, and these states are defined with respect to persistent context or session. So whenever I say persistent context, I'm talking about the session. That's basically what I said here, right? The persistent context is represented by Hibernate session. You can think of persistent context is actually a bag in which these persistent objects are actually located. Okay, so anyway, the domain object could be in three different states: transient state, persistent state, or detached state. So transient state does not belong to persistent context. Persistent state, the object belongs to persistent context, and detached used to belong persistent context. So object, domain object could be one of these three states. Okay, so we're going to actually see these things in example in a few minutes. So if you don't understand what I'm talking about, don't worry about it. For now, just think of persistent context is a bag of the persistent state objects. Okay, so persistent context is represented by Hibernate session. And in JPA, this persistent context is represented by entity manager. And that entity manager in JPA plays exactly the same role as a session in Hibernate. Okay. All right, so let's look into each of these states in a bit more detail. So the transient state. So transient state object, the instance is not and has never been associated with any session or persistent context. Okay, and so let me actually show you transient state as an example. Okay, so this is an example here. When you create an object, that object is in transient state. Okay, now when you save it, it will become persistent state. Okay, so let's go back to the presentation. So transient state, the instance is not and has never been associated with any session, meaning it's not in a bag of this persistent context. Okay, and it has no persistence identity, primary key value called the object identifier yet. When you save the object, then Hibernate will assign what is called the object identifier to that object. Okay, and it does not have any corresponding row in the table because it's not been persisted. Okay. So when poser instance is created outside of the session, meaning before it's persisted or saved, is in transient state. Okay, so that's basically the example I showed you here. When you create an object that is in transient state and it doesn't have any object identifier, it doesn't have any row in the table. Okay, now when you save it, that's the time object identifier will be provided by the Hibernate, and that object will be now in persistent state, meaning it's in a bag of persistent context or in a bag of session. Okay, all right, so let's go back to transient state presentation. So when poser instance is created outside of the session, meaning it was not saved or persisted, it's in transient state. Okay, and the changes made to transient object do not get reflected to the table because in order to get reflected, the changes to be reflected in the table, it has to be changed to persistent state. Okay, so only the changes in persistent state objects will be reflected in a database table when they are committed or flushed. Okay, all right. Okay, so persistent state. So when you save that object, when you save that transient object, when you actually persist, there are in fact two methods, persist method or save method. So when you call one of those two methods, typically save method, then that object will be in persistent state. Okay, so the instance is currently associated with a single session, meaning it is now handled by session. Okay, and it does have a persistent identity called the object identifier, and likely to have a corresponding row in the database table. Okay, if it has been committed before or read from the table. Okay, oops. So if it has been committed before or read from the table, it does have a row. But if it has not been committed before, then it doesn't have any row in a table. Okay. Now changes made to the persistent object, okay, reflect to the database table when they are committed or flushed. Okay. So when you actually, persistence, the object state gets changed to persistent state when the transient object gets persisted through save method. So that is an example I showed you several times. So here, when you create an object that's in transient state, okay, so you make a change, and then when you save that object, in this case person object, then this object is now being maintained by session. Okay, it's maintained in the persistent context. Okay, so when you now commit the transaction, then this person object will be reflected in a table. Meaning, if it is the first time being saved, then new row will be added. If it is the object that reflects the existing row in a table, then the row will be updated. Okay, so you can actually get the object identifiers. You can call get identifier person object, then it will return this object identifier. Okay, and in fact, session also has a method called the contains. So you can actually call session.contains and person. Then, if it returns if it returns true, that means the person object is in persistent state. Okay, if you actually call session.contains here, then you should return false. But once you save, and then if you call session.contains and person, then it should return true. Okay. So that is actually a very distinct state that represent the state of that the object. Okay, so we covered transient state and we covered persistent state. Now there is a third state which is called the detached state. Okay, so detached state is a state of an instance. The instance was once associated with a persistent context. It used to be in a session, but the context was closed, meaning the session is closed. So when the session is closed, all the objects that are maintained by the session will be in detached state. Okay, or if you serialize that object, then it becomes a detached state automatically. Okay. Because it used to be in the persistent context, it does have an object identifier. And it might in fact have a corresponding row in the table if it has been committed or flushed before. Okay? If it has not been committed or flushed before, then it probably doesn't have a row in a table. Okay? But it still does have object identifier. So the reason that you want to create an object in detached state, meaning when the reason you want to convert into detached state is that when you need to send that object to some other tier or program, so that the program or tier will be able to change the state of it. Okay, so you might in fact have some kind of a person object from a database, and then if you want to represent that person object to a web tier so that a user can change the data, then you have to actually send that object in the serialized form to that web tier, right? And that web tier could be in fact a different server, right? Okay, in that case, that object becomes a detached state. So that's when you want to actually create the detached state object from the persistent state object. Now, the changes made to the detached object do not get reflected to the database table right away. They need to be merged before change get reflected to the database table. So detached state is like a transient state, meaning whatever changes you made in the detached state object will not get reflected to the table. Okay, so in order to have that changed detached state object to be reflected in a table, you have to what is called the merge. Okay, so when you call merge, it will actually basically create another object that is in persistent state. Okay, all right. Okay, so the difference between transient and detached object instances. A transient object does not have object identifier, while detached instance has object identifier. So these are the cases where state transition occurs for an object, domain object. Okay, so transient instances will be made persistent state object by save method or persist method or save or update method. Okay, persistence instances may be made transient by calling delete. So when you call delete of an object, basically it is making it into a transient. Okay, and then when they get actually persisted, then the row will be removed from the table. Any instance returned by get or load is persistent state. Okay, because you are basically reading a row into an object, so that is in persistent state. Detached instances may be made persistent by calling update or save or update or log or replicate. Okay? And the state of detached instances may also be made persistent as a new persistent instance by calling merge. Okay, so we're going to actually talk about this merge in a bit more detail. So when you call the merge, it will create a brand new persistent object from that detached the object. Okay, so persistent object in a session becomes detached object after session it belongs to closes. Okay. All right, so let's look into the methods, lifecycle methods of session interface. By the way, session is the interface, but in the real application, the object will be created by Hibernate, and then you can actually call methods of this session, object. So the types of method that you can see in session interface is lifecycle operations, for example, save, persist, get, load, merge, and all those things. You can also actually have, you can create a transaction object from it, and you can also specify locking information. And you can also do some management of resources, and you can also create a JDBC connection. But mostly we are going to focus on lifecycle operations in this presentation. All right, so lifecycle operations. So the things you can do as lifecycle operations include saving object, loading object, getting object, refreshing object, updating object, deleting object, and replicating object. So session provides a set of methods for doing these operations. And as we talked about, calling these methods, lifecycle operation method, will change the state of the object instance. So let's take a look at each of these methods in a bit more detail. So saving object. So an object remains to be in transient state until it is saved. And then once you call save method, then the object is now in persistent state. Okay, so when object is in persistent state, that means that object is now managed by a particular session. Okay. So, again, we use these two terms interchangeably, session and persistent context. Okay, so you can think of them as the same thing. Okay, so you can think of session or persistent context is a back of persistent state object. Okay. Okay, so the method, the session interface has a bunch of the method, and this is a save method. So when you actually provide your domain object instance and call the save method of the session interface, meaning session object, it will return serializable object, and that serializable object is representing object identifier. It returns object identifier as a serializable type. So this is the code that we have seen before. So here we create a person object, then we can make a change, and then we can save that person domain object, and then it becomes persistent state. Okay, and again, if you can find out object identifier by calling. So actually it returns object identifier. Okay, so we did not actually capture that object identifier, but you can get the object identifier by calling get identifier method of that object. Okay, again, it also has session interface also has a contains method, which returns true or false, indicating whether that object is in persistent state or not, meaning it is maintained by the session or not. Loading object is used for loading the object from the database. Okay, and each load method requires object primary key as an identifier. So you have to actually specify what object you want to load from the table. Okay, the identifier must be serializable. So any primitive identifier must be converted to object. Okay. Each load method also requires which domain class or entity name to use to find the object with the ID. So you also have to provide the domain class or entity name. So you can actually give a name to your entity in your XML file or in your annotation. So you can use entity name if you want to, or you can just specify domain class. The return object, which is returned as object type, needs to be typecasted to domain class. And the return object is in persistent state because it is immediately read from the table. So this is the method, load, and you have to specify domain class, and then you have to specify object identifier. Okay. So that's load, and you can also use get method, and get method works like a load method. Okay. So the difference between load and get, you are going to use load method if you are sure the object exists, because it will return object identifier, right? And if there is no the table, I mean a row in the table, then it will throw an exception. Okay, meaning if the unique ID is not found in the database, it will throw an exception. If you're using get, it will return null if unique ID is not found in the database. Okay, so it's just kind of different programming style. So this is for getting objects. So this is a get method, but the parameters are the same. Okay. So here, if you call the get method and you provide the domain class and then object identifier, and if then you're going to cast it because it returns the object type. So you're going to cast it, and then you can check whether that is null or not. Okay, and if it is null, that means there is no entry in the table. Okay, refreshing. Refreshing is used to refresh object from your database representations in cases where there is a possibility of persistent object is not in sync. So the reason you want to refresh object is that you might in fact have an object in persistent state, and you are not sure whether that reflects the correct value in the table. In that case, you can refresh it, meaning it's going to read the data from the table. The reason you might want to refresh is because there is a possibility. If there is a possibility, someone else in fact changed the table. So your Hibernate application is not the only application working with the table, and your application executes some SQL directly against the database table. So instead of actually Hibernate, calls, your application might actually in fact perform some SQL directly. Probably not the good practice. The database use triggers populate properties of the object. So you might in fact have a JDBC trigger, SQL trigger that actually do something to the table. So basically whenever there is a possibility of the table being changed not by your application, then you might have to refresh the object. Basically, this is the refresh method, and you provide the object. So basically, you are rereading the state of given instance from the underlying table. Updating. So when you want to make a change to existing row of the table, then you are going to update. Okay. So Hibernate session automatically manage any changes made to the persistent object. So you as a Java developer will make a change to your Java object. Okay, instead of the table directly using JDBC. Okay. Now, whatever changes you make, if you want those changes to be reflected in the table, then the object must be in persistent state. Okay, so any changes that you make in transient state or detached state, they are not going to be reflected in the table. Okay. So if a property changes on a persistent object, Hibernate session will perform the change in the database when the transaction is committed. Okay. And you can force Hibernate to commit all changes using flush. You can use a flush method. Okay. You can determine if the session is dirty through isDirty method, meaning if any object in the session has been changed or not. Okay. So you can actually call isDirty method. Merging. So merging is actually merging detached the object. So it's basically copying the state of given object into persistent object with the same identifier. Okay, so if you happen to have a detached the object that has the object identifier, that's the time you want to merge. To make the new object that has the same identifier, so if there is no persistent instance currently associated with the session, it will be loaded. And it will return persistent instance. And if the given instance is unsaved, you save a copy and return it as a newly persistent instance. I'm going to actually give you an example code in a few seconds, so don't worry about this, this bullet. The given instance does not become associated with the session. So let's actually see how things work. And we're going to do all these things in hands-on lab, so you'll have ample chance to play around with this. So when you call the P1 object, and if the P1 object is the detached object, and when you call the merge, it will return an object, okay, with the same identifier of a P1 detached object, but this return object is in persistent object. Okay, so when this object is saved, then it will be as this is a persistence. When the transaction is committed, this will be reflected in the row. This one will remain as a detached state. Okay. All right. So finally, to the exercise. So exercise 1. So exercise 1 is we are going to play around with these life cycle operations. Okay. So we're gonna just run the application. So you want to import. Here we are not gonna actually write code step by step. Instead, we are gonna just import ready to run applications. So here I created a working set. So I'm gonna actually import all the project. It's existing Maven project. So in my case is labs and Hibernate Basics. Okay, so I'm going to import all this project. Okay, so we have the set of sample project that are imported. Okay, so the one that we want to try is a save one. Okay, so let's run the save one. Run as Java application. Yeah, you might have to actually do Maven install. Okay, main, and is default package. Run it. And this is pretty much the same code that we have seen. Oops, we have not. We have whenever you actually have the Java net connection, that means I'm not running Java DB server. So because I actually studied the NetBeans, that's why. So I'm going to actually go to services, databases, and start the Java DB server. Okay, so Java DB server is now up and running. Now I'm going to run it again. Okay, so now things work fine. Okay, so pretty much the same code. Okay, so if you take a look at the code, again, you can run it at the command line if you want to. And now let's take a look at the code. Yeah, so this is whenever you see this connection error to port number 1527, that means Java DB server is not running. If you actually get this message, my database was not found, that means you have not created my database. Okay. All right, so let's study the code. So this is pretty much the same code. Okay. So here we created person. So at this point is a transient state, right? And so I'm making a change to a transient state. Okay. Now, in order to make this object to be persistent state, I have to save it. Okay. So I'm going to call save method, and it will return object identifier. Okay. So I'm going to display object identifier, and that's basically this, this guy. Okay, it just displays one and the second object that I created. So you can actually call this one. You can do this way. Okay, by calling get identifier. Okay, and for your own exercise, try to actually call session that contains P1 and see whether that actually returns true or false. Okay, so you can call it here and here. Okay, and see whether that works. Okay. And then here we created the second person object, and so here, yeah, and then we perform commit. Okay, and the person domain class is pretty much what we have seen before. So you have to have NOR constructor. Okay, and obviously we have a configuration file. This is the same configuration file we have seen before, and this is the same configuration file we have seen in the step-by-step presentation. Okay, so that is a save one. Save two, here we are going to, so here, you can see there is only one single row in the table. So in the save two, let's run this code first. And this time we are going to see only one entry, and the reason is because, okay, because if you take a look at the code, okay, so we have transient state object, okay, and we changed to Yongqin, but we did not save it, so this is actually commented out, okay. So now when you actually commit the changes, only the objects that are in persistent state will be reflected in the table. Okay, so because we haven't changed the P2 to persistent state, it doesn't get transacted to the table. Okay, all right, that is the save number 2. The fifth one is a merge. Okay, so when you run the application, so these are the results. So let's just run the 2 sessions merge. This one as main, this default, and this is what you are going to see. Okay, so I'm going to just use lab documentation. So here we are actually displaying ID 1 and 2, and we perform the merge. Okay, and then after the merge, and we actually see the ID 3, and then we actually seeing 3 different entries in the table. So let's take a look at the code. Okay, so we created a session. We're going to actually talk about the concept of session in detail in a few minutes. Okay, so that's actually our next topic. Okay, so but for now, just assume that session is created here. Okay, and what we have done is so basically when we so in this code we create a P1 and P2. Both of them are persistent state until session is closed. So we close the session. Okay, so now P1, P2 objects are now in detached state. Okay, because session is closed. Okay, so if you try to get object identifier, or you can call contains method of the session, it will reflect it's not contained in the session, and it will actually return exception. Okay, if you comment out this code, it will be causing an exception. Now here we are going to create a new session. So this is the brand new session. Okay, now the P1 is still detached state. Okay, so when we change the P1 sanction 2, okay, it is in detached state. Okay, now what we are going to do is, in order to have this P1 to be, the changes in P1 to be reflected to the database table, I have to merge it. So here I'm going to the merge. Okay, so I'm going to merge P1, and it will return another object called the P1 merged. So P1 still stay as a detached, but it will create a brand new persistent state object that has the same object identifier of P1. Okay, so now when we actually call the get identifier, it will actually, the ID1, if you actually see ID1, yeah, so you can see after the merge, it still returns 1, okay, because that is the same object identifier of a detached. Okay, and so that's actually returning 1. And here we are going to create a brand new now this is P2. Now we actually save the P2, and when you actually get the P2, it actually returns 3. Okay, because the table is going to use the new value for assigning object identifier, so it will return true 3. Okay, so that is the exercise. This is a single session merge. So in this case, if you take a look at the code, so we are going to actually look into the patterns that you can use in terms of a session and transaction. So in this case, we have a session, then we created first transaction, okay, and then we are going to the commit, and then we're going to create the second transaction, okay. So P1 is still in state because it has a session is associated with. So that is actually setting, we are changing the value to sanction 2. Okay. And since P1 is still persistent state, there is no need to load it from a database table. So you will not actually see SQL. So here you can actually see there is no SQL being performed to the table. And we actually perform the merge. Okay, and the rest of the code is pretty much the same. So, basically we are actually seeing there is no SQL command to the server kind of thing in this exercise. All right. So in this exercise, the goal is for you to experience the differences between these three states, the transient state and persistent state and detached state. Okay. I want you to do some of your own experimentations, using this code. Again, I recommend you to take a look at the session interface also. So I'm going to just Google Hibernate session API. So if you just Google it, you should be able to see this API documentation. So I'm going to just go to this guy, and you can actually see a bunch of methods. So what we have play around was the save method, right? We save method and the merge method, and we haven't tried the other method, but and the contains method is contains. You can check whether the object is in persistent state or not, meaning whether object is associated with this session or not. Okay, so try to call this method in various places and to see whether they are behaving as expected. Okay, so I'm going to give you guys 15 minutes to try this exercise. So we'll be back 12 minutes after 12. Okay, all right. So let me. So next topic is Hibernate framework classes. So these are the system level classes that we have used already. So let's actually look into these three system level classes: session, factory, session, and transaction. So session is considered as a single-threaded, short-lived object representing a conversation between an application and persistent store. And as I said before, it represents a persistent context. Okay, so easiest way to understand session is basically it is a bag of a persistent state object. Okay, so that's basically what I said here. Persistent context or session is a container of persistent object instances. So persistent object is always associated with a session. In other words, it belongs to particular persistent context. Okay. Again, we are using these two terms interchangeably: session and persistent context. And the session object is, providing methods for performing these lifecycle operations, save, load, get, and all that stuff. And it is a factory class for creating a transaction. So transaction object is a single-threaded, short-lived object used by the application to specify atomic unit of work. What it means is that, with a transaction, you can perform commit or rollback. So whatever operations that you have performed within that transaction will be all committed or all rolled back. Okay. The abstract application from underlying JDBC, JT, and Cobra transaction. One of the nice thing about the Hibernate is that it actually provides the high-level API for hiding the differences between JDBC, JTA, and Cobra transaction. Okay. However, transaction demarcation either using underlying API or transaction is never optional, meaning everything that you perform with the Hibernate is always in transaction. Okay, there is, there cannot be any operation that is done without inside a transaction. Okay. All right, so let's do exercise 2. So exercise 2 is here we're going to actually play around with the transaction without the rollback. So here we're going to actually commit. Okay, meaning whatever changes you make will be committed. So this is without rollback. And the second one is we are going to, the rollback. So we are going to actually observe any operations that you have performed will be rolled back, meaning no changes to the database. Okay. So here we are in fact doing a bunch of stuff. Okay, and you can see this has been changed. Product name new. Okay, so if you actually take a look at what's happening, we're gonna actually take a look at this code in a bit more detail. I'm gonna explain these things, using the code. Okay, so the result is basically something has been changed. Okay, all right, and if you take a look at the code, okay, so we have a session. Okay, from the session, you are going to create a transaction object. So again, session is a factory class for creating a transaction. So everything has to be done within the transaction. Okay. So here we have product, okay, the product which is a transient state at this point, okay, and so wait a minute, product create. Oh, okay. So we actually, yeah, the product is not transient state. I'm sorry. I mean, we actually perform the query operation, so it actually reading from the table. So this is the persistent state, okay. So we make a change to that persistent state object, and then when we commit, that will actually change the data to new value. So that's the reason you're actually seeing product name new. Okay, then we are going to create another transaction. So we create a transaction, and we are going to actually change the product name Sang-Shin. Okay, so we change to Sang-Shin. And then we actually do the refresh. So whatever change you make in your object instance will be, replaced by the value from the table. So the table, the value is set to name new. So at this point, this product will have product name new. Okay, and then when you commit, it will be the same. Okay, so that's basically what you see. Okay, this is the same code. Nothing much to talk about. Okay. The next one is rollback. So in this case, nothing has been changed because whatever change we make is rolled back. So if you go back to here, basically, we make a change, and instead of actually commit, we are going to actually call rollback. Okay. So whatever you make, whatever changes you make to the object will not be reflected. Okay. So pretty straightforward. All right, so I'm going to give you guys about 5 minutes to try this exercise. Next topic is Hibernate configuration. So we actually have some exposure to Hibernate configuration already. So this one, we are going to actually go through those information one more time. So this is the Hibernate configuration file. So here, this is the setting for MySQL database. Typically, when you're using Hibernate, you're using with other frameworks such as the Spring framework. So in that case, you're going to actually set Hibernate configuration information as part of your, for example, Spring framework configuration. So here, since we are using Hibernate as a standalone Java application, we have to provide this information as in the form of Hibernate config.xml file. So one of the things that you have to specify in the Hibernate configuration file, in this case, is the mapping file. Again, this is a case when you provide domain class to table mapping in the form of XML file. Now, object to table mapping. So this is the mapping file we just talked about. So object to table mapping can be done in two different ways. One is through annotations in source code, and the other one is using Hibernate mapping file, which is in the form of XML. So object to table mapping annotation. So this is the same slide we have seen in the step-by-step exercise. So here we specify the entity annotation, and then you can use table annotation for specifying the name of the table, and then you have to specify ID annotation indicating which field of this class will be used for primary key column of the table. And if you want to give a different column name, then you can use column annotation. And generated value annotation is used for specifying what is the key generation strategy that you want to use. And that's something that we are going to cover in a few minutes. All right, so Hibernate mapping file is designed to be readable and hand editable. So it's XML, it's because it's an XML file. The mapping language is Java-centric, meaning the mappings are constructed around the persistent class declaration, not table declaration. So basically, you are actually indicating either in the form of, this is a case that they are using annotation, the actually XML file. Let me see, what is the XML file? Okay, so yeah. So you can, we're going to actually see the example in a few minutes. You can also specify ID generation, versioning, persistent properties, object relationships, and mapping. All those things could be specified in this mapping file or again in annotation. All right, so mapping classes to tables. So if you see the syntax of it, basically you are going to use a class element and then you provide the name of the class. So you specify the complete packaging structure. So my package.answer class, and the name of the table is going to be answer, and then you can have a bunch of other the attributes. Okay, so we're going to actually look into these attributes in a few minutes. So this is more complete, the syntax of class attribute, a class element. Okay, so the most important thing is again name of the class and table name and discriminator and bunch of other things. Okay, so as you can see, you can specify optimistic locking, lazy, and these are the things that we are going to look into later on. You can also specify entity name. Okay. Okay, so let's look into some of these attributes of the class element. Again, name is fully qualified Java class, and table, the attribute is optional. If you don't specify table, then it's going to use the class name as the name of the table. And discriminator value is again optional, and the value that distinguishes individual subclasses and used for polymorphic behavior. So we are going to actually cover the Hibernate mapping. So when there are relationship between two objects, meaning two classes, in the form of inheritance, meaning one is a parent class and the other one is a child class from that parent class, how we are going to actually deflect that relationship into the table. And in that case, there is in fact what is called the discriminator value that actually specifies what is the name of the column, and that column should actually indicate what subclass is actually for that particular entry is all about. Okay, but if you don't understand what I'm talking about for discriminator value, don't worry about it. We'll actually look into this one later on in Hibernate mapping presentation. So for now, important attributes are name and table. And for dynamic update and dynamic insert, it specifies update SQL should be generated at runtime and contain only those columns whose value have been changed. Okay, same thing for insert SQL. So if you set to true, that means insert SQL will be generated at runtime and contain only the columns whose value are not null. Okay, and optimistic locking determines optimistic locking strategy. Okay, so you can set it true, then that means you're using optimistic locking. By the way, that's the default. So if you don't specify anything, then default value of true will be used. Okay, so we are going to look into optimistic locking in the Hibernate transaction and concurrency presentation tomorrow. Okay, so that is a mapping between class and table. Now, how we can map properties of a class to columns. So this is an example. So property, the name is reason, so that is the name of your field, property of your Java class, and the type, and update insert column and column. This is the name of the column in the table. Okay, not null true. So this is an example. More complete attributes of property elements is like this. Okay. All right, so a little bit of explanation of name of the property of your Java class, and the column is the name of the table column, and unique, enable DDL generation of unique constrained for the columns, not null is actually nullability of the column. Optimistic locking, you can specify the optimistic locking for that particular column and generate it. Default to never specifies that this property value is actually generated by the database. Okay, so moving forward, mapping ID field. ID field is special, so you can specify which field of your Java class is supposed to be used as an ID. So you are going to use ID element, sub-element, and then you can also use generator sub-element with a class attribute, which specifies a key generation scheme. Okay, so we're going to look into a set of key generation schemes, including increment and the identity and UUID and things like that. Okay, so we're going to look into that in the following slide. Okay, so that is a key generation. So it could be increment, it could be identity, it could be high-low. So increment basically is identifier. The primary key is going to be generated in the form of long, short, and int, and it basically gets incremented. Identity is supported in DB2 MySQL, the Microsoft SQL Server, Sybase, and Hypersonic SQL. So Java DB doesn't support identity. So for playing around with the identity key generation, we are going to use MySQL. High-low is using high-low algorithm. And assign is the application is the one that actually assigned an identifier. So this is the case that it is the application's responsibility for assigning the key value. Okay. Native, it picks identity, sequence, high-low depending on the capabilities of an underlying database. So it basically, depending on which database is using, it will just choose native, the scheme. Okay, and that could be identity, sequence, or high-low. UUID is using 128-bit UUID algorithm to generate identifiers. All right, so let's do exercise 3. So exercise 3, here we are going to play around with various schemes. So increment, assigned, UUID hex, and then identity. Again, identity, you have to use MySQL. Okay. So in this case, increment is if you run the application, it's actually exactly the same code, okay, which we have seen before, okay, and basically we are specifying generator the class increment, okay, and when you actually display the application, it's basically ID. You can see ID is 1 and 2, okay. And assigned is that assign is a case that application has to assign the value. Okay, so in this case, we are assigning 233 and 411. Okay, so ID is set like this. So if you take a look at the code, okay, so here we are going to use a setID method. Okay, to that object, and here we are setting 233 and 411. Okay, and that is going to be used as an ID. Okay, in this case, the class attribute value is assigned. Okay, UUID. So this is the value of UUID. Okay, and you can see those UUID values are actually used as an ID in this case. Okay, and in this case, the same code, but here we are using UUID.hex. Okay, that is the value of UUID. The generated primary key value. And the last one is identity. So in this case, because JavaDB doesn't support identity key generation scheme, we are going to use MySQL. So make sure your MySQL database server is still up and running. Okay, and when you run it, this is what you're going to see. Okay, and in order to use identity, you have to actually create a table using auto increment. Okay, so for this person table, you instead of this, just comment this out and then use this one. Or you can just change the existing code with, you can just add the int auto identity here. Okay, and you also have to specify primary key. Okay. and here we are using identity. Okay, so if I run the code, so I'm going to just try to use MySQL. Okay, so I'm going to run the application. It's the main method. Okay, so works as expected. Okay, all right, so I'm going to give you guys about the 10 minutes to try this exercise. Last topic is data access object pattern. Basically, our pattern is separation of data access logic from business logic. The idea is that your business logic should be hidden from the underlying implementation of database, the access logic. I think one of the questions that was asked was, whether Hibernate can actually access the MongoDB or NoSQL kind of things. It doesn't, because Hibernate is designed for mapping between object to relational database. These days, the companies and organizations are using a different database technologies, the MongoDB and the relational database. And even in relational databases, you might want to insulate your application from database access APIs, whether that's a Hibernate APIs or whether that's a JPA APIs. That's basically what this style pattern is all about. It's basically insulating your business logic from your data access logic. So that the data access logic or even a database server technology could be actually changed without affecting your business logic. Okay, so enables easier replacement of the database, the technologies, or the APIs without affecting business logic. Okay, so you can implement our implementation strategy, runtime pluggable through factory class, or you can actually have interface and implementation. So idea is this. This is an interface. So basically you can see create, delete, find, and find all and update. And these are all business level APIs. Okay. And how these APIs are implemented underneath, that's the implementation detail. And that implementation can change what you placed. Okay. All right. So let's take a look at exercise 4. So here. Basically we are running this application. One is using implementation, one is using class, and the other one is the interface. So if you take a look at the code, this is a business logic code. So in the main, assuming main is a business logic code, it actually create the event object and set name, and here is using what is called the create high-level API. Okay, and this create method doesn't actually expose any implementation detail of underlying database. In fact, it could be MongoDB, or it could be relational database. Even if it is a relational database, it actually hides the API level as well. So basically, create and find and update, these are all application level APIs, which do not have to be changed when you're actually changing your underlying APIs or database technologies. Okay. All right, and then you are going to provide the actual implementation class. So this is a class that actually implement the real persistent logic. So this is a case where you are in fact using, in this case, Hibernate API. So here we start the start operation is actually a method that we created here for creating a sessions and all that stuff. Okay, and start operation basically creating a session and transaction. And then we are basically in this create, then we save it and then we commit. Okay, so the APIs are captured inside the create. So this is the implementation detail. Okay, and this code be changed without affecting the main.java, which is representing business logic. Okay, so that is the code. And then this is event is again the application level code, and everything else pretty much the same. Okay. In this case, we are using interface. So here, basically, instead of actually a class, we are using interface. I mean, this is a better programming practice, right? Okay, because the implementation can actually change without affecting this code. Okay, so in this case, in this model, because we are using class, if you're actually changing this class, then you have to change this code, right? So that is not a good practice. Instead, you want to use interface. Okay, so that is the next exercise. We are using interface rather than implementation. All right, so that is pretty much it. So we have interface and then you have implementation. Okay, so this implementation is implementing this interface, and this class, you could in fact have another class that implements this interface, and that implementation will replace this one without changing the business logic. Okay. All right, so that is pretty much it, and I'm going to give you guys about 10 minutes to try this exercise, and then we're going to move on to the next topic. Okay. All right, let's stop